Okay, let's get started. Starting with this equation here, we want to not have the square root anymore. As you will remember, squaring the square root cancels it out. And so we just have to square the other side. There's nothing else that we could do about that because we definitely want to cancel out that square root. So we get x plus 3 equals x squared plus 6x plus 9. And we have a quadratic equation, so we'll get one side to be 0 by subtracting x and subtracting 3. So we get x squared plus 5x plus 6 equals 0, a factor, x plus 2, x plus 3. That means one of these has to be 0, so x is negative 2, or x is negative 3. And those would be the solutions that I'd write here in the answer line. Alright, solve this equation. First, let's start by getting the thing that's in the parentheses raised to the fraction power by itself. So we'll subtract 12 to start with. So we have 3 times 16x plus 21 to the 3/5. Hopefully you can read that. Let's get the calculator out. Turn it on. 387 minus 12, 375. Then we'll divide by 3. And I'll bring it up here. 16x plus 21 to the 3/5 equals 125. Okay, to cancel out this 3/5 power, let's raise it to a 5/3, because when we raise a power to a power, we multiply the powers together, and 3/5 times 5/3 is 1. So we'll just have to multiply or raise this to a 5/3 power. Okay, 16x plus 21. So what's 125 to the 5/3 power? Well, it's the same as saying the third root of 125 raised to the 5th power. That's going to be 5 to the 5th. And use my calculator here. 5 raised to the 5th power, 3125. Then we'll subtract 21. It's all down here from all downhill from here. 3125 minus 21. 3104. Then of course we're going to divide by 16. 194. So we'll just jump down to the answer. X equals 194. Alright. Here we want to cancel out a cubed root, so we'll cube both sides. X minus 3 equals 27. We'll add 3 to both sides, and x is 30. Alright, the sales of a certain product after an initial release can be found by the equation S equals, and all that stuff, where S is the represents the total sales, so this is the number of sales. T represents the time, so any time you plug in here, any number of weeks we plug in here, multiply by 5, take the square root, multiply by 15, add 53, that tells us how many sales we should have at the end of those T weeks. Weeks since the release. How many weeks will pass? Okay, so we want to know what T is before the product reaches 275 units. So 275 is the number of units, and we have to figure out how many weeks it will take. So the number of sales is 275. We just need to find T, solve for T. So we'll take 275, we'll subtract 53, 222. So then we'll divide by 15. 14.8. Make sure not to round, right? 14.8. It's already pretty simple to write. Don't round it to 15 or 14. Square root of 5t. We'll square both sides. 219.04. Again, don't round. It's important. Equals 5t. We'll divide by 5. 43.8. Let's see, the nearest week it says. So 43.8, that would be, the nearest week would be 44. It'll take 44 weeks before we get to or beyond 275. At 43, we won't be quite to 275. 44 will be past it. All right, here we'll divide by 3 on both sides, getting that x term by itself. 192 divided by 3. 64. raise both sides to the 4/3 power. X equals, okay, what's the third root of 64? Then we'll take that number to the 4th power. So the third root of 64 is 4. We'll raise that to the 4th power. I feel like it's 256. So that'd be 64 times another 4, really. 256. So X is 256. Alright, another word problem here. The velocity of sound. You may not have known this, but the velocity of sound changes with the temperature in air. So the air is the medium through which sound travels most of the time, and the thickness, so the density of that air, changes the speed of the sound. So the velocity of air is given by the equation this, where v is the velocity and T is the temperature in Celsius. Let's see, velocity meters per second. So if the temperature is 321, if the velocity is 321 meters per second, so that's the velocity, 321. That's plus T. So we'll divide by 20. I'll find out what that is. 321 divided by 20. 16.05 equals the square root of 273 plus T. We'll square both sides. 257. Let's see, that's going to be 257.6025. You know, we would write that there. That would be when we square. And then we've got 27 plus T equals this number, so we'll subtract 27 from it. And T is 230, what's it say, round to the nearest degree. So let's see. I don't know what just happened. We'll square it and subtract 27. Oh, not 27, 273. Oof. So here we'll add 27 to get back to what we had, and we'll subtract 273, negative 15 degrees. There we go. Okay, we're going to skip the graph of this function, so let's find some, it doesn't say anything about X Intercepts, so we'll find vertical and horizontal asymptotes. The vertical asymptote, that is a vertical line that's telling us really what problems, what X values have issues, okay? What value of X has an issue here? 0 is that X value that has an issue. It would make the denominator 0. That's no good. What about that horizontal one? Okay, remember the horizontal asymptote is what y gets close to as x gets big. So let's think about x getting big. 1 over a big number, 1 over a million. That'd be pretty much 0. Plus 4 would be pretty much 4. So we're going to get closer and closer and closer to 4 the bigger x is. Those horizontal dotted lines are hard to draw. So that is that number 4 is what we're going to get close to as x gets very large. Not saying anything about what's happening in the middle, but as x gets very big, we're going to get closer to 4, because if, say, this is 100, that'd be 1 over 100. It's 1 100th plus 4 is 4 and 1 100th. It'd be 4.01. Very barely not 4, right? Just very barely bigger than 4, right? So we will draw that horizontal line to help guide us. And now, let's see, it doesn't say X Intercepts, so I could find it, but I just won't bother. Let's find some points. That should be enough. We'll plug in a point on the left of the vertical asymptote and on the right. It should get us going. Negative 1 and 1, those should be easy. Put in a negative 1. I put the 1 in the wrong place. 1 should go there. Negative 1, that's going to be 1 over negative 1 is negative 1. So 4 minus 1 is 3. And for 1, that'd be 1 over 1, that'd be positive 1, plus 4 is 5. So -1, put a point there at y is 3. Here we put at 5. So it's going to come close to this vertical asymptote but never cross it. Okay, and so should make it go up like that, cross like that. This one's going to go down as it approaches the vertical asymptote, and then it will approach that value of 4. So again, we're going to find X intercepts, vertical asymptote, horizontal asymptotes. So let's start with those X intercepts because it mentions it first. Why not? So the X intercept, that's anywhere along the x-axis, and that's where y is equal to 0. So we could start from the, like pretending like we don't know anything about this function really, but say that, well, what x value will give me 0? Well, here we will multiply the left and right side by x minus 3 to cancel out these denominators. Well, 0 times x minus 3 is going to be 0, so it turns out that the numerator is the only thing that needs to be 0. And if x is -5, that will happen. So there is an X intercept. Alright, now let's talk about a vertical asymptote or asymptotes. That would be any x value that is bad, right? And a bad x value here would be 3, because 3 minus 3 would be 0. So we'll put our vertical asymptote at 3. And we'll plot some points. Oh, horizontal asymptote, that's right. What's going to happen as x gets to be very large, try it yourself, put in 1005 over 997 is going to be very close to 1. Remember how they, numerator and denominator both have this degree of 1. They both have the same degree. So they're going to approach whatever the ratio of this coefficient over this coefficient is. Right. And so we have x-intercept, vertical asymptote, horizontal asymptote. Next thing to do is some points. How about 0? We'll plug 0 in there. We'll get -5/3. That'd be right there-ish. Alright. Let's move over here. Let's plug in like a 4, I guess. That'd be 9. And then 4 minus 3 would be 1. So it'd be 9 over 1. I don't have quite enough room for that. I'll just jump over to 5. 5 plus 5 is 10. 5 minus 3 is 2. So we have 10 over 2. That'd be 5. So that's easier to plot. Nothing wrong with that. So we got 0 and 5, and then, well, I kind of don't really need a point over here. I'll show you why. I found one x-intercept. There's one and only one x-intercept. So I know that as I go through this point, I should go down as I approach the vertical asymptote, because it's not going to go up and cross the x-axis, because I didn't find an x-intercept. Okay, now what do I do about this x-intercept? Should it come down? Well, I know it's going to approach this value of 1. I know I could find a point over here. It's just going to tell me that I cross the x-axis and come up into the positive values. But that's not a big surprise since I know that it's going to approach 1 as x goes to the negative. And here, I know I'm going to go up as I approach the vertical asymptote because I don't have an x-intercept. It's not going to go down as it approaches the vertical asymptote because there's no x-intercept there. And then I know it comes and approaches this horizontal asymptote. Alright. X-intercepts, okay, so now we know that it's just when the numerator is equal to 0, and x is -4/5. So -4/5 is our x-intercept. Good. Vertical asymptote. That would be any value that causes the denominator to be 0, so we'll set the denominator equal to 0. That should be a plus 10 equals 0. And then we factor x plus 5, and x plus 2 works. So x equals -5, and x equals -2. Those are two values that will cause the denominator to be 0. And so we'll give ourselves a little note for the future. Don't cross over those x values. Horizontal asymptote, what's this function going to do when x gets very large? Well, the denominator is squared. It's got an x squared. So even if I put 1,000,000 in there, I got 5,000,000 over 1,000,000 times 1,000,000. This number is almost 1,000,000 times bigger than this. Okay, it's huge, gigantic compared to whatever this is. Okay, whatever is in the denominator is gigantic compared to whatever's here. So small number, relatively small number, over relatively large number is going to make a small number. So we're going to draw a horizontal asymptote at 0. Because as x gets larger, the smaller the y value is going to get, the closer it is going to get to 0. That helps us. Okay, now let's just plot some points. Let's plot something to the left, in the middle of these two, in the middle of these two, and to the right of this x-intercept. So let's try 0 is easy. 4 over 10 would be 2 over 5, so 2/5. All right. Somewhere in between negative 4/5 and negative 2, negative 1's a nice candidate. So negative 1, that's 5 times negative 1 plus 4 over negative 1 squared plus 7 times negative 1 plus 10. So negative 5 plus 4 over, let's see, this is 1 minus 7. That's negative 6 plus 10. That's negative, no, that's positive 4. Positive 4. Okay, so negative 1/4 is what that would come out to be, negative 1/4. All right, so I know that it's going to go down as it approaches the vertical asymptote because there's no more x-intercepts. It doesn't go up. It'll come through this point, okay, and then I know it's going to come back down and approach 0, so I'll just make it come up a little bit and then come back down and approach that 0.
Please excuse the interruption, please release.
All right, next we are going to look here, and pretty much we're going to find either a kind of a parabola shape up here or down here. We know we don't cross the x-axis because there's no x-intercepts, right? So we're just going to plug something in quick right here, like negative 3. Plug in negative 3, that gives us negative, I've got the actually right here, negative 15. No, I don't have it right there. Negative 15 plus 4 over, if we plug a negative 3 in there, we'll get 9 minus 21 plus 10. I'll grab a calculator real quick. Actually, no, that's not too hard. Negative 11 over, let's see, we got 19 minus 21, so that's negative 2, so 11 halves, 5 and a half. 5 and a half. So we know that it comes down through this point, back up. It doesn't go down as it approaches either of the vertical asymptotes because there are no x-intercepts. All right, and this last one, we know that it either comes down like this and approaches the horizontal asymptote, or like this and approaches the horizontal asymptote. So let's plug in negative 6 and figure out exactly what's going on there. Negative 6. So that's going to be negative, well, that's what we have here. Negative 30 plus 4 is negative 26. If we plug in negative 6, we got 36 minus 42 plus 10 is 4. Negative 26/4 is going to be close to negative 6. It's going to be negative 6 and 1/2. So negative 6 and 1/2. So the graph goes through like this. All right. Last graph. X-intercepts. So we'll set the numerator equal to 0. X minus 3, x plus 1, 0. So x equals 3 and x equals negative 1. 3, negative 1. All right, vertical asymptotes. Let's set the denominator equal to 0. Plus 4 minus 1, x equals negative 4, x equals 1. Negative 4 is well, that's actually a vertical asymptote. 1, that's bad. If x were 1, that'd be a bad deal. So we put vertical asymptotes there. And horizontal asymptote. Let's see, the numerator and denominator now both have degree 2. So if we put in 1,000,000, we're going to get some big, big number. This number is going to be very, very close to being the same. So it's going to be close to being 1. So let's plot some points. Let's go with like 4, I guess. We'll plug in 4. We get 4, we get 16 minus 8 minus 3 over 16 plus 12 minus 4. So we're going to get 5, it's going to be a 5 here, over 60 plus 1 is 28, minus 4, 24. 524, it's not very big, just, what, barely bigger than 1/5. Alright, kind of hard to show. There we go. Next, we'll go with a 2, we'll plug in a 2. And that will give us 4 minus 3, so the 4's cancel, 4 plus 6 minus 4, the 4's cancel there too, so we get negative 3 over 6, negative 1/2. Negative 1/2, so 4 gives us a negative 1/2. We can fill that in, we know it crosses through the x-intercept, approaches the horizontal asymptote, and it must go down towards the vertical asymptote because it's not going to come back up because there's no x-intercept there. Let's plug in a 0, that's going to be easy, 3/4. Negative 2. Negative 2 is going to give us 4 plus 4 minus 3 over 4 minus a 6 minus 4. So 8 minus 3 is 5 over negative 6, negative 5/6. Negative 5/6. So we got 3/4 here when we plug in 0, negative 5/6 when we plug in negative 2, so we go crossover like this, and we go up as we approach the vertical asymptote, not down because there's no x-intercept, and we go down as we approach the vertical asymptote. And over here, actually, we don't even have to plug in a point, because let's look at what we know. We know there's no x-intercept. We know that either the shape is going to be something like this, right, going up towards the vertical asymptote, and then we know it would approach the horizontal asymptote. If it came from down here, it would have to cross the x-axis to go and approach the horizontal asymptote that we know it approaches. So it can't do this. It can't go through the x-axis. We didn't find any x-intercepts. So it must just be something like this, and that's perfectly fine. Okay. Last page. Okay, we're going to simplify this rational expression. The only way you can simplify a fraction is if it has common factor in the numerator and denominator. The only way we're going to know the factors of the numerator and denominator is to factor the numerator and denominator. So we'll factor the numerator and denominator. We got n minus 4n plus 3 over, what does this factor as? N plus 3 and minus 1. So the n plus 3 and n plus 3 divide each other out, and we have n minus 4 over n minus 1. Essentially what we have here is one big fraction because we're just going to multiply numerators and denominators, so we can just treat it like one big fraction. Look for common factors again. This will be x plus 5 times x minus 5. This will be x plus 6 times x minus 2. Okay, so x plus 5 cancels with, oh no, x minus 5 cancels with x minus 5, x minus 2 cancels with x minus 2. We have x plus 6 over x plus 5. Last one, every time I see division by a fraction, I always just change it to multiply by this the reciprocal. So x squared plus 9x plus 20 over x squared minus 25 times the reciprocal would be times x minus 4 over x plus 4. And we'll factor, this is x plus 5 and x plus 4, this is x plus 5, x minus 5. X plus 5 and x plus 5, x plus 4 and x plus 4. So we get x minus 4 over x minus 5. That's the last one. Thanks for watching. Let me know if you have any questions.